And now, I'd like to introduce our presenter. Greg Shumack, Senior TCB Reviewer, is a veteran of the wireless regulatory industry, serving for a dozen years at the Equipment Authorization Branch at the Federal Communication Commission. Greg has reviewed thousands of devices for compliance with the FCC and ISET Canada rules and is on the board of directors of the Telecommunication Certification Body Council, also BC. Greg has given lectures, sermons, and presentations for a variety of audiences and continues to tackle complex devices applications. So, without further ado, let's turn our attention to radio frequency exposure requirements for wireless applications with Greg Shumack. Hi, Greg.
Hey, Kim. How are you doing this afternoon?
I'm doing great.
That's good. So I need to share my content.
Yes, I'm very excited about this topic.
There we go. All right. Well, as Kim said, we're going to be talking this afternoon about RF exposure requirements here in North America, FCC and ISET for both the United States and Canada. I'd like to welcome all of you and thank you for taking time out of your busy schedules to sit in for this talk. I hope everyone has been doing well. It's been a long, hot summer and the new reality of global pandemics. And I hope and pray that everybody has been doing well as they can in this new 21st century reality. The particular topic we're going to be talking about today is an extremely important one. Obviously, exposure is one of the most important things that we look at when it comes to equipment authorization type situations. Just a bit of background on myself. I started working for the FCC a very long time ago when I got out of college, more than 30 years ago in the late 80s. In 1989, I went to the FCC laboratory and began working on equipment authorization. I stayed there, and I was active in testing, developing test procedures, rulemakings, and such. Then in 2000, when the certification function of the FCC was privatized and the TCBs were created, I left the FCC then and have worked for a couple of different TCBs. Since that time, for the last 5 or 6 years now, I've been with American Certification Body, ACB, as a reviewer there, where I review applications for these types of devices and occasionally give talks like the one I'm giving this afternoon. So, just to make sure if anybody has any concerns right up front that this is going to be an extremely technical talk on SAR measurements, rest assured that it's not. It's going to be a very general overview of RF exposure requirements. It's not going to require any in-depth knowledge on your part at this time of specific, for example, SAR measuring techniques. This is certainly not, don't have the time in 1 hour to go into that level of detail. So it's going to be a very high-level view that really is intended to provide both manufacturers and test labs with a general understanding of what the requirements are, when the requirements apply, how to apply them, and what to do in those types of situations. And that's really kind of a how-to introductory type of presentation that I will be giving today. So obviously, as I said, this is a very important issue, RF exposure safety. Historically, at all of the TCB workshops that I've attended, which for the last 20 years has been, I think, almost all of them, traditionally RF exposure always gets the lion's share of time when it comes to introducing the new technologies, new requirements, new policies, new test procedures, and things of that nature by the FCC. And so you could see the amount of importance that they place on it simply based on that, if not on anything else. Of course, there is the ever impending threat of lawsuits that we hear about over people claiming to have gotten cancer from their cell phone and things of that nature. And all of these things really just help to keep RF exposure front and center when it comes to the importance of its compliance and equipment authorization. The main documents that we're going to be talking about today from the FCC side is their KDB or Knowledge Database Publication 447498. And for Canada, for ICED, it's going to be their Radio Standard Specification RSS 102. When we're talking about RF exposure in general, there are two main types of assessment, and there are actually now going to be a few additional ones on top of these for some odd cases that we're starting to see, and we'll talk about that a little bit later in this talk. But the two primary things that you're going to tend to see are going to be either SAR or MPE type measurements. Very simply put, SAR measurements, specific absorption rate measurements, are applicable when the separation distance between the radiating element of the transmitter and the human body is less than 20 centimeters. When that separation distance is greater than 20 centimeters, then SAR is no longer applicable. You can no longer do SAR in those types of far field situations, and instead you do a MPE, maximum permissible exposure, which is really dealing with the power density at that point. It can either be a power density measurement that you make in the air with a field probe, or it could be power density calculations based on the radiated power, antenna gain, conductive power, distance separation, things of that nature. And we'll talk about that in some detail a little bit later. Just so you know, all of the basic limits for human exposure are based on actual SAR limits, the actual amount of heat per kilogram that the body can absorb without beginning to cause thermal damage to those cells. And I think I'll talk about this a little bit later, but note that it's really just thermal damage that we are protecting against with all of the RF exposure requirements instituted by the FCC. They all focus specifically on potential thermal damage to the cells. Over the years, there's been a lot of talk about various studies that talk about other potential effects of RF exposure on the human body, including like to the blood-brain barrier in the skull, but there's not been sufficient research to pursue that any further at this point. As far as I know, there's not a whole lot of funding for that type of research even available right now. And so primarily we do look at thermal damage or potential thermal damage to human cells. Getting cooked by your phone, basically, is what we're concerned about. So we'll start out and look at some of the requirements here in the United States of America. There's three different categories of devices when it comes to RF exposure categories. Those three are fixed, mobile, and portable, and we'll talk briefly about each of those now. A fixed device is typically a device whose antenna is going to be mounted on a tower, like for broadcast purposes, perhaps on the rooftop of a building somewhere in a downtown area. A tall building will have a lot of antennas typically mounted on its roof. But these are usually associated with broadcast services, almost always licensed services. Not necessarily, but that's typically the case, that these are associated with licensed services. And licensed services, in addition to having the equipment authorization requirement, a licensed service and device must also be site licensed. In other words, there must be a separate authorization granted for an approved piece of equipment to be licensed to operate at a particular location. And it is during that licensing aspect of the equipment that RF exposure is addressed for these types of devices. And for example, when I first out of college came to the FCC, I worked in the FM branch of the Audio Services Division downtown before I came out to the lab for equipment authorization. And in the FM branch, one of the things that we had to always look at when we did licensing was exactly how many antennas were going to be on a particular tower. If they're adding a new antenna, how much additional field strength is that going to cause? We would have to do all the math and calculate exactly how far from the base of the tower a fence has to be put up around the tower in order to keep people away from the tower when the antennas on the tower are transmitting. So for fixed devices like that, all of that RF exposure compliance is typically determined during the licensing stage and not during the equipment authorization stage. Moving on to the things that we have to deal with more from equipment authorization perspective in RF exposure are mobile and portable categories. A mobile category is defined as a device, a mobile device is defined as that which is typically used at 20 centimeters or more from the person. This is specifically listed in section 2.1091 of the FCC rules. The limits are given in a different section, 1.1310. This limit, this is a power density limit that's expressed in specific absorption rate terms. In other words, how much can the human body absorb? And it's a limit that's in milliwatts per square centimeter. If you take a look at 2.1091, you will see that it has various types of categories. It has devices that are excluded from routine evaluation for RF exposure compliance, and those devices that are not excluded from routine evaluation. So dealing with a negative here, so you have to be a little bit careful, but basically if a mobile device that's being operated at 20 centimeters or more from the person, if it is excluded from routine evaluation, then you may determine, that doesn't mean that you don't have to address its RF exposure. You still have to address its RF exposure compliance, but you may do so using mathematical calculations. You can just, and they're pretty straightforward and simple, and I have some examples a little bit further, a few slides from now. So if the device is excluded from routine evaluation, then you may address its MPE compliance through mathematical calculations. For very low power type devices, typically found under Part 15, devices whose limits are typically expressed in terms of field strength. And I'm thinking about devices like under 15209, 15231 for security remote control, your key fob transmitters, things like that. Those are such low power that the FCC does not even usually require any type of addressing of MPE for those types of devices because their maximum limit is well underneath all of the thresholds and exclusions for RF exposure compliance. But if that device is not excluded from routine evaluation, then power density measurements must be performed. In other words, with a field probe, you cannot simply use calculations. Calculations are applicable when the device is excluded from routine evaluation, but when it's not excluded from routine evaluation, then actual power density measurements must be made. When it comes to a lot of Part 15 unlicensed devices, typically MPE calculations are usually usable. Those are your spread spectrum devices under 15247, where you might find Bluetooth and Bluetooth-related devices, ANT Plus, and all of those various flavors. The 2.4 gigahertz portions of 11B, 802.11b, G, and N that operate there. But also millimeter wave devices that are operating up in the 50, 60, 70 gigahertz range and higher, unlicensed PCS devices, and NII devices. All of these are going to typically be able to use MPE calculations when addressing RF exposure compliance, though some 15E NII devices, because they have the ability to have a fairly high radiated power level, they might no longer be, they might miss the exclusion. They might actually be subject to routine evaluation when they have that higher ERP level, in which case measurements would be required in that case and not calculations. And then licensed transmitters, again, depending on their frequency and their power levels, might or might not be able to use calculations. They might have to resort to actual measurements. When you are determining what type of levels you're looking at with maximum permitted exposure, in the power density levels, you are supposed to use the maximum average output power of the device. The maximum average output power, not peak, but average. And the reason is, again, this is based on the heating of body tissue over time, the potential thermal damage, and thermal situations are always caused by the average level of the power being involved. So we're looking at the maximum average output power level that would be used in these MPE calculations. Note also that when it comes to the difference between RF exposure versus EMC, There are differences in the way that you actually calculate what duty cycles are. For EMC purposes under Part 15, for example, you can oftentimes use 100 milliseconds as your maximum period. If you look at, I think it's 15.30, 31 or 35, you can use 100 milliseconds as your maximum period in determining the duty cycle. When it comes to RF exposure, those times are greatly increased. For MPE, they starts out at 2 or 3 seconds and goes up to as much as 30 seconds. And for SAR, it can go considerably higher than that, as a matter of fact. And so since we are looking at potential heating issues with tissue, those averaging times are stretched out to greater lengths like that. And so it's really the duty cycle used for RF exposure is a very different animal than that which might be used for EMC type compliance. Now, it is possible, though, to include source-based time averaging in your calculation of what that average output power level might be. And the classic example is time division multiple access type devices, where they have a certain amount of time slots, and it's a function of the modulation format that ensures that the transmitter is only going to transmit during certain time slots and must be turned off during other time slots because those are the slots used on the receive end. And so when you have something like that, that's what the FCC would consider to be a source-based type of averaging. It's not averaging based on the usage or intended usage of the device or what the end user might set it at. It's something that is actually source-based in the device itself, basically hardwired into the device. So when it leaves the factory, nobody, not the installer or the user, can ever make any changes or adjust that duty cycle or increase it in any way. When that's the case, then you may use that type of averaging in your calculations to determine the average power level for the purpose of MPE calculations. Typically, if you're going to do that in an application, note that there should be an attestation included in the application in which the applicant or manufacturer attests to the fact that the duty cycle being used in the MPE or RF exposure calculations is indeed source-based and cannot be used by the installer or cannot be changed by the installer or the end user. When we start looking then at when we look at how we inform the user on whether a device is considered to be mobile or not, the FCC will allow warnings in the user's manual to ensure that it's used always at that minimum separation distance of 20 centimeters. But the FCC will only allow that when it's actually reasonable when you look at what the device actually is, and if it could potentially be used in a portable configuration, which would be a less than 20 centimeter separation. So, for example, a laptop or a phablet or a battery-powered router or something like that might indeed be something that's used within 20 centimeters of a person. Same with a USB dongle. It could be plugged into a laptop. And I think I addressed a specific situation that arose recently with regards to that. And I'll talk about that a little bit later in this presentation. But if the device includes a lanyard or a clip for a lanyard, then it's something that can be carried on the body and can be resting directly up against the body and potentially used in that situation. And so it would not be mobile. It would have to be portable in that situation. And for that matter, any device that has a carrying strap that allows you to use the device while it's within 20 centimeters of the body, all of those things would then require a portable category, as opposed to trying to say that it's mobile, even if it's only usually used in mobile situations. You have to look at every possible worst-case scenario. And, of course, remember that that includes any part of the body. If it's something that's handheld, it still would be a portable device. It's used within 20 centimeters of the body, even though it's not maybe worn on the body or held to the head. The mobile default separation distance for mobile operation, the typical minimum separation distance is 20 centimeters. That's by definition, that anything at 20 centimeters or more is considered mobile. When you look at the grant of authorization, typically the grant should say, according to the FCC, something along the lines of, this device is approved for mobile operation with respect to RF exposure compliance. So if it doesn't list a distance, but it says mobile, then you know that it has to be the default distance of 20 centimeters. The FCC has indicated that they would like to see that distance listed on the grant itself only when the distance exceeds 20 centimeters. And even in that case, a lot of times they will also permit something to simply say at the distance specified in the filing. But recognize that if it's a mobile device, it's going to state that in some way or another on the grant of authorization as well. This is a table that shows the MPE limits. You can get these also, as I said, out of the FCC rules as well. You'll note that there are two sets of limits, one for occupational and controlled exposure and a second for general population and uncontrolled. I'm not going to be talking too much about those two things today, again, mostly due to time. The vast majority of equipment that gets approved for the general population uncontrolled exposure requirements on the lower half of the table in section B there, on the lower half of the screen. The controlled or occupational type limits are higher limits, but in order to apply those, you have to show that the person that is using the device has been actually trained in the use of the device and trained in ways in which they can mitigate their RF exposure while they're using the device. And the FCC requires proof of the training, special notices to go in the manual, special labels to go on the device, a lot of hoops you have to jump through. And as a result, a very small percentage of equipment actually gets approved for the occupational or controlled exposure limits. Almost always they're going to be end up being certified to the general population or uncontrolled limits. And for Part 15 devices, which are unlicensed, there's no choice in the matter. They may only be authorized under the general population uncontrolled exposure limits. Licensed devices may, under very special circumstances, be authorized using the controlled limits. So, as I said earlier, when you're doing your calculations, you're looking at the maximum possible average value. And this is not necessarily just the measured value that was measured in the lab, but rather this is the target value for every device that's going to be rolling off of the assembly line. So oftentimes you might have to take that measured value, and then if the manufacturer is aware of what their target is and what their acceptable tolerance, their acceptable production tolerance is, then they should include that information in the application. And it's that target value, maximum target value plus acceptable tolerance that's used for the average level of the power that you use in the MPE calculations. Not just the level that was measured on the device that was sent it to the lab for testing. In some cases, if the manufacturer is not sure what their target level might be, and this happens a lot of times when a manufacturer might buy, for example, a whole boatload of Bluetooth or wireless LAN transmitter chips, where the entire transmitter is on a single chip, and they bought 10,000 of them, but they're not exactly sure. They'd have a range of power levels, they know, but they're not exactly sure what the target might be. In those cases, it oftentimes is done that they will simply estimate, maybe say a 10% markup on that maximum level measured in the lab would cover any production tolerances, but it should be addressed in some manner or another. Because of that, this is why a tune-up procedure should also be submitted even for Part 15 devices subject to RF exposure compliance, like 15247 or 15E, if that tune-up procedure is available. And it's precisely because the main thing we're interested in is not how the device is tuned up, but rather what that maximum target output power level will be and what the acceptable tolerance, production tolerance is on top of that. And again, the goal is, because you always want to use the absolute worst case possible power level to ensure that any device coming off of that assembly line is going to meet the appropriate RF exposure compliance limits. This was the example I mentioned earlier. This is actually taken from a test report that's publicly available on the FCC website. You see the general equation there at the top, and the reference to this is FCC's OET Bulletin 65. The power density is the EIRP, the power times the gain over 4 pi r squared. 20 centimeters is the minimum for that you would use for R when you're doing calculations for a mobile device, and you see if you comply with the specific limit that's listed. Moving on now to portable categories. Excuse me. Portable devices are those devices that are used within 20 centimeters of the body. The rules for these things are specified in Section 2.1093 of the FCC rules. The limits are also included in that section. The limits are specified in terms of watts per kilogram. Again, we're looking at the amount of energy that is absorbed by a certain amount of human tissue. 2.1093 will state that the SAR can be evaluated either through measurement or through computational modeling. And just as an aside, only actual SAR measurements can be assessed by a TCB without the use of the PAG procedure. That's the pre-approval guidance procedure. In other words, if you are using computational modeling to show compliance with your device with the applicable SAR limits, then that application is also going to have to be reviewed, or that aspect of the application will also have to be reviewed by the FCC in addition to the TCB before the grant can be issued for that. SAR testing is very important, or computational modeling. Again, we're talking about the compliance of devices that we all and our kids and our grandparents all hold up against their heads and hold in their hands and against their bodies. And certainly we want to make sure that they are not being harmed by any of that. This whole RF exposure issue, especially for portable devices, really kind of exploded on the FCC almost without warning, I want to say. That fateful day back in the mid-'90s. I was actually at the FCC laboratory the night before one of the news programs, 24 Hours, or one of those nightly type investigative news programs, had done a segment, and I believe Connie Chung actually was the reporter who was doing it, about a man down in Florida who was using a cell phone. At the time, mobile phones were about the size of a shoebox, basically. But he had been using one for an extended period of time and unfortunately developed a tumor, brain cancer, and he thought it was because of the phone and the usage of the phone, because apparently it was in the same part of his head where he used to hold the phone up against. So after that show aired on ABC or NBC or whatever network it was, the next day, the FCC phone lines were literally overwhelmed with thousands of phone calls of people calling in and saying, I just bought one of these new devices. Is it going to give me cancer too? The FCC had never been the FCC's responsibility to address RF exposure, particularly portable exposure like this. FCC had always been involved simply in equipment authorizations. Does it interfere? Does it write the bandwidth, the power correct, all that kind of thing? I was at an emergency meeting was called between a lot of people at the FCC laboratory at the time and the FDA, because the FCC's initial position was that this should be something that the FDA covers and not the FCC. At this particular meeting, they had a lot of the top FDA scientists stand up and basically say, we don't really know anything about near-field stuff. It's black magic as far as we're concerned, and we think the FCC needs to regulate this. And FCC, of course, FDA is a huge, powerful federal agency. FCC is the smallest of all federal agencies with the fewest number of people and the smallest budget. But the FCC got stuck with ensuring the compliance of these devices with RF exposure requirements. And so the FCC really had to scramble at that point to come up with all the requirements and the test procedures and things. And so this has been a big deal ever since then. And if you've never been involved with it, SAR testing is extremely expensive. Many tens of thousands of dollars go into SAR testing of a new 4G or 5G phone, for example. And computational modeling is also extremely expensive. That can take literally weeks of computer time to get that type of thing done. And so these are big, important things that also cost manufacturers a lot of money to make sure that they're done correctly. And so there's a lot of effort put in from every aspect to make sure that everybody fully understands what is needed and when it is needed. And so you can see also in 2.1093, they have certain devices that are excluded, just as they did for mobile. But The exclusions are far fewer in this section here. Almost all of the Part 15 stuff that I show there, that's not excluded from potential SAR testing. The only things that tend to be excluded are the very low power Part 15 types of devices and a few of the different licensed services that are a little bit on the more esoteric side. But there are new rules that the FCC has that should be issued and become effective sometime in the coming months for RF exposure. And one of the things that those new rules do is it eliminates all the exclusions when it comes to portable devices. And basically all portable devices are going to be potentially subject to SAR compliance. Now, a non-excluded transmitter may still avoid a SAR test by using the SAR test exclusion equations in the KDB, and we'll talk about that in the coming slides. Here you can see the actual SAR limits that are listed here. The whole body limits are things that are used actually in Europe. These are whole body measurements over 1 gram. The FCC actually uses the partial body limits here in the United States, as does ISED. So in North America, we use the partial body limitations there, especially looking at the Section B for the general population. That's a 1.6 watts per kilogram. That's the typical number that you'll see when it comes to compliance of cell phones and other types of portable devices like that. It's going to be 1.6 watts per kilogram for the body and for the head, and 4 watts per kilogram for extremities, hands, wrists, feet, and ankles. And the reason that the extremities have a higher limit is because it's the damage that we're looking for and to protect the human body from is thermal damage. And the portions of the human body that are most subject to thermal damage are the wet tissues, including fat tissues, muscle tissue, brain tissue. Skin and bones is not as susceptible to thermal damage, and the cells that make up your skin and bone structures. And since your extremities tend to be mostly skin and bones, they can actually withstand a fair amount more thermal energy before they start to show any sign of potential damage. So when it comes to portable type devices, again, we're looking at the maximum average power because we're looking at how much heating it does to your tissues. You can take source-based time averaging into effect, again, like that TDMA example we had for MPE, but you cannot do something based on usage-based averaging. It has to be something, again, similar to MPE. It has to be hardwired into the device and a true source-based type of averaging. When it comes to hardwiring it, in today's day and age, of course, you can use firmware to hardwire something. And you'll see that a lot of devices will use firmware to reduce the transmission times of a wireless LAN due to actual needed requirements. And the first example is the common one that's given for these e-books, where it's really a very low duty cycle. They're downloading a page at a time for people to read. And so they can afford to enforce some off time through firmware into those types of transmitters. And they do that specifically so that they can use a higher power when they are on and meet their needs that they need for the link and still be able to meet the RF exposure requirements by having an average level low enough to meet all of the limits. Another example is push-to-talk radios that are held in front of the face. There's actually an entire KDB publication that's been written and issued by the FCC specifically dealing with the compliance of those types of devices with RF exposure and SAR. Again, SAR results are scaled up to consider the worst-case target or tune-up power, similar to what we mentioned for MPE. This is oftentimes referred to by the FCC as the reported SAR, and that is the measured SAR level that has then been scaled up to compensate for how the power level of the measured device compared to what the maximum possible output power target level is plus tolerance. And so you would scale up your measured results in order to get a reported result that, again, would cover, in theory, every single unit ever rolling off of the assembly line. The FCC does have a requirement that says that because scaling is not always accurate and there can be a lot of different factors that can affect its accuracy and precision, for that matter, that the device that's tested still has to be at least within 2 dB of its maximum target or rated power. In other words, you don't want to be scaling it up too much beyond that. The FCC also expects that they only require that you test a couple of channels across the band, but they do so based on the expectation that the power levels are flat across the band. If you have a situation where, and you see this again many times in wireless LANs, where channels in the center of the band might have 5 or 6 or 7 or 8 dB more power than the band edge channels. They purposely bring the band edge channels down to help them with band edge compliance issues. But the test lab might or might not be aware of this, and so certainly it behooves the manufacturer to inform the test lab of the fact that they do not have flat output power levels across their entire band. And it's something that's an important issue. SAR tests are completely dependent on the particular host, antenna, and accessories. And again, the reason is we're looking at near-field issues here. And near-field issues are very much dependent on the particular configuration of the components involved. High-gain antennas really have no effect on localized SAR values whatsoever. And as a matter of fact, in most cases, the majority of cases, the SAR hotspots that you see are not even at the radiating element of the antenna, but rather at the feed point of the antenna. And that's across the board, that's a common thing to see. And so the gain of the antenna, it really does not come into play because SAR is a near-field measurement. And that means when you were taking those classes in college and they had all of the extra mathematical terms and the teacher would say, assume far field, and you could cross out all of those terms. When it comes to SAR, you can't cross out all of those terms. You need to take them all into account. That's why you need to have a computer doing the actual conversion of the measured data into a number that's a meaningful number that you can compare to the limit. All of the accessories and attachments that might be used with the device, again, have to be considered during the SAR evaluation. Doesn't mean that they have to have full tests with all of them. Oftentimes, for many accessories, the FCC will say, take your worst case usage configuration from no accessories, add the accessory, and just test it one time in that configuration. So there are ways to avoid having to retest everything. But all of your different accessories and attachments still must be considered in one way or another because, again, in the near field, all of them can have an impact on the actual SAR levels being absorbed by the human tissue. Any type of body-worn test distances must be appropriate and realistic. Most people are not going to get away with saying that they have a smartphone that they always keep at least 2.5 inches from their body. I mean, we all know that smartphones are put in our pockets. And so, you know, that's something that has to be a realistic type of a distance that's being used there. As I mentioned earlier, a SAR test is not always needed. A SAR assessment is always required, but that does not necessarily mean that the test will also be required. In KDB 447498, there are SAR test exclusion equations provided that cover a lot of different scenarios that you can use to step through and fill out the equations and figure out if indeed your device is actually going to require that SAR test or not. Just as an aside, I noted here in the EU, it's simple. They just say it's a 20 milliwatt threshold. In North America, it's a little bit stricter than that. We have a little bit stricter requirements here for SAR than they do in the EU. And it's a little bit trickier. We take more factors into account in determining when SAR testing can be excluded and when it is required. And so, as I said, there are multiple equations in the KDB publication. They talk about various circumstances dealing with separation distances, operational frequencies, and things of that nature. If you follow it carefully, it's very clear. There's a lot of steps involved in some of these equations, but they are very clearly written out, and they're very easy to follow if you just take your time and go through it. Quoted here a little bit from one of the particular, this is one of the standard equations here. This is for in the frequency range of 100 megahertz to 6 gigahertz. So that pretty much covers the entire SAR measurement range that robots are capable of, and probes exist for that range. and at distances of less than 50 millimeters or less than 5 centimeters. And then, so if your device is something that might be worn in the pocket or kept in your pocket, but it's a very low-power device, it's some kind of a BLE, a Bluetooth low-energy type device that you know has only got maybe a milliwatt or two of power, then indeed you might be able to plug those values into this equation to determine if, and in that case, you would not need to get SAR testing. And so the equation is simply that the maximum power, and this maximum power is that tune-up power that we talked about earlier, the maximum target plus production tolerance. That maximum power divided by the minimum separation distance in millimeters, and that minimum separation distance, if it's something that's going to be held in the pocket or something where it might be a zero, in actuality a 0 millimeter distance, for the purpose of this equation, you would use 5 millimeters there. And then you take that quotient of the max power divided by the minimum distance, you multiply it by the square root of the frequency in gigahertz, and you come up with a numerical number. There's no units for it. It's a numerical value that you compare to this threshold of 3.0. And if your numerical value is less than 3.0, then this device is excluded from having to actually be tested for SAR. And in the application, you would simply have a 1 or 2 page document that goes through these calculations and shows that it meets this SAR test exclusion. Some of the details are written here. The results are rounded to 1 decimal place. You round everything to the nearest milliwatt and nearest millimeter before you do the calculations. When the minimum separation distance, if it's less than 5 millimeters, you would use 5 millimeters. But this is the basic equation that you would use. If you're then looking at a device, you say, well, my device is something that's only held in the hand or maybe worn on the wrist. But again, it's a very low-power device. So you feel that you might be able to get away and meet the SAR test exclusion threshold. Here's the equation that you would use for meeting it for the extremity. And you'll notice it's exactly the same equation, but the difference is that the threshold for body worn and for held to head was 3.0, and now for extremities, the threshold is 7.5. So again, you would do the same numbers, plugging in the tune-up power, the minimum distance, the frequency, and determine if you meet that threshold or not. If you're less than that, then SAR testing is not required. If you exceed it, then you're going to have to get SAR testing performed. Wrong direction. There we go. And here are some of the other, they take these equations then and expand them for different scenarios, such as keeping it at the same range, 100 megahertz to 6 gigs, but separation distances greater than 20 millimeters or less than 20 centimeters. Of course, at 20 centimeters and greater, it becomes MPE, and SAR is no longer applicable. Then they have equations for frequencies below 100 megahertz at different separation distances. And all of these equations are included in the KDB publication. Excuse me. Now, if we're looking at a device that has that includes multiple transmitters, and that's extremely common these days, the typical smartphone probably has 7 or 8 or more transmitters embedded in it. So the idea of having multiple transmitters in a device is something that certainly has to be taken into account, both from an EMC perspective, but for the purpose of this talk, for an RF exposure compliance perspective as well. Now, please note that, and you'll see this in a lot of the grants of some older devices, older grants that were issued, say, more than 5 or 6 or 7 years ago. You will see things like no co-location permitted. And the FCC really has been trying to get TCBs to move away from that type of thing, because it's not that no co-location is permitted. If 2 transmitters are in the same box, there might be no RF exposure issues from their co-location at all if they're not capable of transmitting simultaneously. And so the real issue that we're interested in here is the simultaneous transmission of co-located devices. And the FCC defines co-located as being within 20 centimeters of one another. So if you have a device, and your device might be a decent-sized device, maybe a printer or something like that, and you've got one transmitter in one corner and the other in the opposite corner on the other side, they might be further than 20 centimeters apart. In that case, you would address RF exposure compliance for each of those two transmitters individually. But if those two transmitters are less than 20 centimeters separated from one another, then you cannot look at them individually. You must look at their summation and compare their summation to the RF exposure limits. Now, just as a side note, technology handoffs of less than 30 seconds are not considered to be simultaneous transmission. In other words, if you're going from a licensed voice connection outside and you walk into your house and your phone automatically switches over to your Wi-Fi to continue your conversation there might be some simultaneous transmission that goes on there for a short period of time, but typically it's a lot less than 30 seconds. So handoff times like that, as long as they're less than 30 seconds, do not count as simultaneous transmission. And what we're interested in is real-world operation. In other words, some manufacturers think, oh, I have to put my device into an artificial mode where I make everything transmit at the same time. Well, you don't have to do that if that's not how your device is going to operate. What we're really interested in is how will your device operate in the real world? If there is the remotest possibility that two co-located transmitters could simultaneously transmit, well, then in the interest of looking at all worst-case situations, you have to deal with that co-transmission scenario. But if there is no possibility for two transmitters to transmit simultaneously, then you can deal with them individually. And the classic example of that is when you might have separate wireless LAN and Bluetooth transmitters that are sharing a single 2.4 gig antenna, a very common occurrence. And in those situations, you will never have the wireless LAN and the Bluetooth transmitting simultaneously because they're sharing the same antenna. And so in a situation like that, you can see that there is no chance of simultaneous transmission, and you can deal with the two transmitters individually for their own individual RF exposure compliance. So how do you determine if a device complies and it's got multiple co-located, co-transmitting transmitters? Well, for MPE, the simplest way is to simply do your calculations and get your different MPE or power density levels from the different transmitters, add them all up, and if the sum, after you've added them all up, is still less than the limit, then your device complies in that co-located, co-transmitting scenario. Now, what oftentimes happens is because the limits change with frequency band, you cannot maybe apply the same limit to all of the different transmitters in the device. So in that case, you would look at each individual transmitter's MPE level when compared to its own limit. So if the limit of the first transmitter is 1.0 and it's running at 0.8, and the limit of the second, and so that's an 80%. It's 80% compliance. It's up to 80% of its limit, and the second device's limit is 2.0. And it's operating at 1.0, well, then that's 50% of its limit. You would add the 80% and the 50%, and if they exceed 100%, then the combination does not comply. But if that two percentages are less than 100% or equal to 100%, then you can say that the combination does comply. And if it doesn't comply, it doesn't necessarily automatically mean that it's the end. At that point, you can go through and look in the publication. It gives you potential details for dealing with the situation, other options and things to look at. Alternatively, you can talk to a TCB or the FCC directly in order to work out what your next steps might be should you find that your percentages exceed 100%. When it comes to portable devices subject to SAR, again, the easiest thing to do is to measure each SAR level individually and then add them together. In this case, again, the limits would have to be the same. You would have to take all of the body SAR type levels or head SAR, and those would be separate from the extremity SAR summations. But in either case, when the limit is the same, you can sum up the SAR levels. You really, with today's SAR systems, it's very difficult, if not impossible, to actually perform a simultaneous SAR measurement on multiple transmitters that are transmitting simultaneously. And that's because you are typically limited by the software, by your fluid parameters, and by the probes, which are not necessarily going to be able to cover the ranges involved in what we see in different co-transmitting, co-located transmitters. And so instead, you would measure them individually. If the summation meets the limit, then you're good to go. If the summation does not comply, then you can actually look at the locations of the hotspots of the SAR values for the different transmitters, and the KDB provides calculations that you can use based on the physical distances between those hotspots to reduce the summed level, the interacted level, so to speak, based on the distances apart that they are, how far apart the two hotspots are. And you can oftentimes apply those equations to bring your numbers down so that you will comply. A worst case scenario is if that does not comply either, then you might have to go on and physically do some measurements of the device simultaneously operating. And in that case, you need to contact the FCC ahead of time and work with them to develop the appropriate test procedure, or the SAR lab would have to work with them to develop the appropriate test procedure for that to happen. Here I just have quoted a little bit of the information. I think we're getting close to the end, so I'm going to move through this quickly so I can get into Canada. I quoted 2.1091 here, and it talks about how mobile device is defined as being used in other than fixed locations, such that the separation distance is normally maintained between the transmitter. And I was just pointing out that generally and normally are used there, so we're not talking about absolute worst case scenarios, but something that has to be realistic. Oftentimes this means that it might have to be further than 20 centimeters from the body if the worst case scenario brings it in to close to 20 centimeters. And this does not apply to things that you would just push, like the classic example is the doorbell. A doorbell, even though you have to touch it for an instant, you're only touching it for an instant, and the rest of the time you're going to be more than 20 centimeters away. The FCC allows you to apply mobile MPE type calculations to show compliance for that particular type of device. But anything that's held in the hand when used, or worn on the body or on the arm, those things are going to have to be considered portable. And so a few questions here about different types of devices. Are they mobile or portable? And I'm going to, again, go through these kind of quickly. You can go back and look at the details. USB dongles are considered portable because they might be in a laptop that might be on your lap. Of course, anything worn on the wrist or ankle is portable because those are considered part of your body as well. Things that you might just occasionally touch, like a television or a projector or that doorbell that we were talking about. In those situations like that, that will typically be mobile. But if something's got a carrying handle, or a carrying strap, and the user's manual shows that you can use it while carrying it like that, well then, again, that's probably going to be portable. Laptop computers are considered portable, again, just by their very name. Cameras are portable. There might even have to be a face SAR assessment because you might be holding the thing up to your face when you're taking a shot. Handheld readers and tools are portable. Lastly, from the FCC side, I want to touch on just a couple of recent developments. 447498 does not address RF exposure for frequencies greater than 6 gigahertz, particularly for portable devices. And so the FCC has recently, since last fall, allowed a test exclusion for portable devices that operate over 6 gigahertz and that operate at 1 milliwatt or less. And so that test exclusion is in place, but all other portable devices that operate over 6 gigahertz are handled on a case-by-case basis with the FCC through KDB inquiries and then the PAG process in order to determine the proper way to address RF exposure compliance. The new FCC rules that are in the works, and they're waiting on some administrative issues before they actually become effective, but probably in the next couple of months, are going to also begin to require nerve stimulation assessments for low-frequency operation, similar to what ISET has been doing for the last couple of years. And then finally, when it comes to RF exposure for wireless charging devices, there are a lot of variations for these types of devices. And so once again, they have their own KDB publication as well for dealing with RF exposure compliance. Here I have just listed some KDB publication numbers and the specific areas that they deal with for RF exposure compliance with these types of devices. These are KDB publications that deal with RF exposure compliance for different technologies, for test methodologies, equipment approval policies, and the rest. Moving along to Canada, and I have fewer slides. Generally, the Canadian outlook on this is fairly similar to the FCC's. Their RF exposure requirements are controlled by, used to be Industry Canada, now it's Industry Scientific Educational Department. I don't remember the acronym, but ISED. Health Canada is another a group, a government group that influences the requirements. And both in the U.S. and Canada, the governments are set up such that consumer groups also have a voice in determining what a lot of these rules and regulations are, and all that gets taken into account when these rules and regulations are written. Typically in Canada, their thresholds are a little bit stricter than the FCC levels. There was no real scientific evidence or data given for their decision to do that. Might have been potentially more of a political decision, just so they could say that they have the safest products in the world, perhaps, or perhaps Canadians are more genetically subject to RF exposure damage. We're not sure exactly what the real reason was, but they did change their limits a few years ago and make them a little bit tighter than those of the FCC. When it comes to portable or less than 20 centimeters, they have an assessment threshold listed in RSS 102, section 2.5.1. It's a series of tables with frequency ranges and separation distances. And if the output of your device is lower based on either conducted or EIRP than the level in the table based on the frequency range and separation distance, then you do not have to test it for SAR. But if you exceed those levels, then SAR testing is required. Just as a note, ISED also accepts use of several of the FCC's KDB publications with respect to SAR testing. You can look on the ISED website, and they actually have a list of specifically which ones they accept. For MPE calculations over 20 centimeters, in section 2.5.2, they have some power levels there. If your device, and again, conducted or radiated, if your device exceeds those power levels, then you are not exempt and you actually have to perform the MPE calculations. So the first step for MPE is you compare your power levels to the exclusion table. And then if you exceed those levels, then you do the MPE calculations, similar to what you did in the example that I showed earlier for the FCC. The only difference is that the ISED limits are a little bit tighter in general than the FCC's limits. ISED has also made it clear that they expect that the bystander must be considered when assessing RF exposure, not just the user. And for example, if you're always standing next to someone with a device in your hand, and that device has been designed to not radiate back into your hand, but outward, but you've got it pointing outward right into another person, then that might be cause for concern for that other person. And the place that this actually originated was concern for children in schools. So they thought if you had a bunch of kids in rows and desks, and they have laptop computers, and the laptop screen is open, and there are some transmitter antennas in the top edge of that screen, that might only be 8 inches away from the back of the head of the kid sitting in the desk in front of that person. And so for those reasons, they want to ensure that any bystanders around these devices are also protected from potential RF exposure issues. And so you have to address not only the user, but also potential bystander issues when you're dealing with RF exposure for Canada. Occasionally, they change their RF exposure requirements that are listed in RSS 102. And in some cases, that change can trigger an automatically required reassessment of devices that were previously certified and might even be in the field already. In other words, there are times when they allow no grandfathering of previously approved devices. And this happened in recent history 2 times, both in 2015 and in 2017, where they required that the manufacturer or the applicant assess even devices in the field to ensure that the devices that they've been selling in the field meet the new RF exposure requirements for Canada. And if they didn't, they would require that steps be taken to change them. This is pretty unusual when you have a certification process like Canada and the FCC have. Normally, rule changes would simply grandfather things that were previously approved. But in this case, RF Exposure Canada has a couple of times done something which is more similar to what they do in Europe with the supplier's declaration of conformity in Europe, which is a continuous reassessment. Anything coming off the assembly line today has to meet the rules that are in effect today, that kind of thing. And for a DOC, that's maybe a little bit more common, but for a certification program, not so common. Canada basically takes most changes like that, and they do internal risk assessments and determine if they can avoid having to do a continuous reassessment. But I guess in the case of RF Exposure, they felt it was important enough that they actually required fielded units to be reassessed to demonstrate compliance with the new requirements. Almost done here. For Canada, nerve stimulation exposure requirements. This is specified in the supplementary procedure SPR 002. Applies to things that operate in the range of 3 kilohertz to 10 megahertz, regardless of output levels. These are measurements made with a probe. The test lab has to be accredited for that and also recognized by ICED. That accreditation for this specific type of testing must be recognized by ICED. That caused some problems initially because not too many labs had that accreditation that was recognized by ICED, but nowadays many more of them do. Again, this is something that the FCC will also begin to institute probably within the next year, if not less. For higher frequency type devices, they have already begun to require a case-by-case assessment of localized power density for portable devices operating over 6 gigahertz. This is really exactly what the FCC has done as well, stating that all of these devices, portable devices over 6 gigs, are addressed on a case-by-case basis. ICED is anticipating a release of a new SPR 003 to address radio frequency exposure compliance specifically in the 57 to 71 gigahertz band. And they also point to this IEC TR 63170 as an international document already in place that talks about how many of these measurements can be made. Finally, FCC, as we said earlier, excludes a number of things from potential testing. When it comes to a lot of these things, for Canada, there's no exclusion. You always have to address it, but that might be just simply a matter of doing calculations. So we recommend that you always try and address it, even if they're not necessarily going to be required in the end, because there are plenty of times when ICED will come back and specifically ask that it be included in the application if it has not been included already. And I think I'm a few minutes late. I apologize for that, but that pretty much wraps it up. This is, again, a pretty high-level view of RF exposure requirements in North America for both FCC and ICED. Didn't have the time whatsoever to dig any deeper into the details, but if you do have any questions about any of these things that we've been talking about, my contact information is here at the back of the presentation, which I think will be sent out to you all, I suspect, when Washington Labs finishes up. So, Kim, I'm pretty much finished up with this. I will get it back to you.
Thank you so much, Greg. By chance, did you have any time to answer a few questions?
Absolutely.
All right. Before I ask the questions, I just wanted to say that some of the comments I've seen, people were coming in late. No worries. That is true. I will be sending out the recorded presentation along with the presentation slides to everyone who has registered. So you will get that. I usually do that within 1 to 2 business days after the live webinar. So it's safe to say, if for some reason you don't get it by Tuesday, please reach out and I will make sure you get it. All right, on with the questions. There was a question that said, are there any differences between RF exposure requirements in U.S. and in Europe?
Yes, and there are, as a matter of fact. And this particular, again, with an hour, you saw I was running over just trying to get through North America and moving through things really quickly. So just didn't have the time to put the European requirements in here as well. But yeah, there are requirements in Europe. I mentioned just very briefly, for example, for SAR, they do a whole body as opposed to a partial body limit. For SAR, I believe their MPE requirements are very similar to the U.S. requirements. I wouldn't bet the farm on that. I haven't looked at it recently, but I'm pretty sure that they're fairly similar. So they have a lot of similar types of requirements. They just have slightly different limits, maybe some different bands where different types of tests are required. But overall, they're kind of similar to what we've seen here in North America. It's primarily some of the details on the tests and the limits that are different between Europe and North America.
All right, thank you for that. The next question is, car telematics, hopefully I said that right, device falls in which of the three categories?
A I see the questions here. Let me take a look. Car telematics device. So if this is a transmitter that's located on a car, okay, most likely that's going to be a mobile device, especially if the antenna might be like a roof-mounted, mag antenna, magnetically held-on type of antenna that goes on the roof, or some of them might be mounted on the bumper. For some of the lower frequency ones, I've seen the long whip that goes from the front bumper over the top of the car and again to the back bumper as well. So those types of devices typically are going to be considered mobile devices. Now, again, depending on the specifics of the car telematics device, I mean, if it's got some type of voice thing where it's used in the console or between the seats or something like that, then possibly it could be within 20 centimeters of a person's thigh if they're sitting in the driver's seat and it's in the console to their right. So a lot of it has to do with where the different radios are installed in the vehicle. But typically they're going to be more than 20 centimeters away, or I should say, maybe not typically, but if they're going to be more than 20 centimeters away, then they would be considered a mobile device with respect to RF exposure compliance. And if the radiating element, can be within 20 centimeters inside the vehicle, then it would have to be considered a mobile device in that situation.
Okay, our next question. If a product complies with SAR and or MPE requirements per FCC and ISIT, would it also comply with international requirements too, such as 62311 or the 62409?
Again, probably not, because at least in the case of SAR, it's a different type of measurement. We're looking at partial body measurements, the 1 gram cube measurement in North America for partial body. And I think it's a 10 gram cube for Europe on a whole body type measurement. So it was a single measurement, but made by the SAR machine basically, but all of the DPS and things like that has to go on, then calculates and changes those values based on exactly what you're measuring there and how you're measuring it. And so certainly for SAR, it's not going to be the same. North American requirements are not going to be equivalent to the European requirements when it comes to SAR. MPE, again, I think that at least in some cases, I seem to recall, and it's been just too long since I looked at it, but for EU, they're very similar to the U.S. on MPE. And again, I think Canada is tighter than either on MPE.
Okay, and the last question I see is, the vast majority of modular approvals seem to be for use at greater than equals 20 centimeters. However, I've seen a few older grants allowing use at less than 20 centimeters. Under what circumstances is a grant like that allowed?
Well, basically, when it comes to modules, it's rare, but it is possible that a module can be approved as a portable device. And it is possible to test a module for SAR, depending on specifics of the module. But it's not a very common thing, and there's a lot of hoops that you have to jump through in order to do that. And part of the reason also that the FCC is not real crazy about that is because when you look at a portable device, especially a small portable device like a cell phone, for example, you've got all kinds of electronics and transmitters crammed into a very small physical space. And so even a module that might comply standalone in a SAR test, if you could somehow press the module up against the phantom, underneath the phantom there, even that does not necessarily mean that when you put that module into a cramped device like a cell phone, that the SAR is going to continue to comply. And this is one of the reasons why the FCC, and I believe I said, do not even permit you to get a modular approval for something that's going to be used in a small portable device. The reason most modules will get the mobile classification and show compliance with the mobile limits, is 20 centimeters or greater, is simply because it's a lot easier and cheaper. SAR testing, as we talked about earlier, can be tens of thousands of dollars, whereas to show compliance on the MPE side, it's 5 minutes of math that you do, and submit that, and you're good to go. And so, from that perspective, the mobile authorization is much more attractive. It's much quicker and much cheaper. And then what typically happens is most module manufacturers, when they do this, they will tell you, if you're interested in buying one of their modules, they'll say, well, look, if you want to put this into a device that you're going to use in a portable configuration, you're going to have to go and get SAR testing done on it, or at least an assessment to see if it meets the SAR test exclusion thresholds potentially. But they might do that as a permissive change then to cover a portable configuration in your specific host device, or they might ask that you reauthorize the module under your own ID, and then you can do anything you want with it. You can put it in any host as long as you get all the required testing performed. So typically it's easier for the module manufacturers to start out with it being mobile and then work with specific customers if they have a portable configuration in which they'd like to use their particular module.
All right, that was the last one. Did just come in. Let me ask this question, and then that'll be it. These requirements of RF for wireless applications, the effect on living with safe biological way.
I'm sorry. Can you let me see that, please? Let's see if I find it. Requirements for yes, that's what we're talking about. Is hopefully that's the case, and that's the whole point of this RF exposure testing, is that we want to ensure that the effect on living creatures is not going to be harmful to them in any way whatsoever. I did notice also, Kim, there was one other. Here we go. There was one other question I saw earlier: how to deal with the USB dongle containing an RF device put in a laptop. This will increase the total RF level. Yes, indeed. There are specific test procedures in place for installing a dongle into a typical laptop and then testing that for SAR, where you actually will hold the laptop, put it upside down with the dongle in place at the side, a USB slot, turn the laptop upside down and put it against the bottom of the Phantom, and then have certain specific measurement distances between the dongle and the Phantom. And so in that case, you would be able to measure the SAR from that dongle. Typically, the FCC has said that unless the dongle has some physical characteristic that prevents it from being plugged into a laptop, then you must treat the dongle as a portable device. In other words, you must assume that it can be used within 20 centimeters of a person because it might be used in a laptop computer. There was a situation that I came across, I was personally involved in about 2 years ago, where they had a dongle that plugged into a big device that was used in the basement for security and things like that. It was not intended to be used in a laptop. It didn't even have drivers on it that you could plug in for like Windows or anything like that. It was a Unix type thing. It was specifically designed for this big device, but the FCC still required that they consider it portable and get SAR testing on it, because they said there's nothing that's going to keep someone from plugging it into their laptop and downloading drivers and trying to run it. And the quote from the FCC at the time, and the manufacturer said, well, we put lots of warning labels saying that they can't do this. And the FCC's response was, you have to test to make sure the device is not going to harm the general public, even when they don't listen to your instructions. In other words, it was the FCC considered it the manufacturer's responsibility to ensure that their device is going to be safe, even when it wasn't used in the way you're telling people to use it. But because it was simply possible to use it in a different way, it had to, that particular configuration had to be covered and addressed in the authorization. So you basically, the only thing that I've seen where they were able to avoid getting the dongle approved as a portable device is they actually had like a plastic mounting on the end that prevented you from plugging the USB into a standard USB connector on a computer, and it could only be plugged into a specialized USB port on a specialized device. So that physically prevented the dongle from being plugged into the laptop. In that case, the FCC said, yes, you can treat that as that dongle as a mobile device and not portable. But if it doesn't have something that physically keeps it from being plugged into a laptop, lack of drivers is not sufficient, then that dongle must be considered portable. I think that might have been all the questions. So thank you so much, Kim.
You're welcome. And once again, if we did not get to your question, please feel free to send your questions to either the email that Greg provided or right here in front of you, questions@wll.com, and I'll make sure Greg gets that question. Greg, once again, thank you so much for taking the time out to enlighten us about radio frequency exposure requirements for wireless applications. It was a very informative webinar. Our next upcoming webinar is covering tests and approvals for Japan, which is actually 2 weeks from today, September 3rd at 1 p.m. Eastern Time. If you haven't already done so, make sure you visit our website to register for this webinar if you're interested. On behalf of the Washington Labs Academy, I would like to thank you all for attending. I will now go ahead and end the event. Enjoy the rest of your day, and most importantly, be safe. Thanks, guys.